Here's the most unsettling thing about this story. Researchers didn't need exploits. They didn't need to reverse engineer model weights. And they didn't need access to any backend system. They just told the AI that 2 plus 2 equals 5. And that was enough to make it ignore its own safety rules. Not metaphorically, literally. A web page containing a false mathematical statement was enough to destabilize the model's sense of what rules apply to it. If that sounds absurd, it should. And that's exactly the problem. Let's actually look at this. The surface story, as reported by Ars Technica, is about a new class of attack targeting AI-powered browsers. Tools like browser use, convergence, and the agent layers being built on top of models like GPT-4o and Claude. These are products that let an AI model autonomously navigate the web on your behalf, filling out forms, booking things, pulling data, executing multi-step tasks. They're being positioned as the killer app for agentic AI, the thing that moves LLMs from chat windows into actual workflows. The attack researchers documented is called a dream world attack. The mechanism is a specific evolution of prompt injection, where malicious instructions are hidden inside content the AI reads while doing its job. Here's what the headlines missed. This isn't just another prompt injection variant. The dream world framing points to something more specific. The attacker isn't just issuing instructions, they're first corrupting the model's epistemic context, its operating sense of what is true. By asserting false facts, even something as trivial as 2 plus 2 equals 5, a malicious web page can nudge the model into a state where its normal guardrails no longer feel coherent to it. The rules were written for the real world. If the model accepts it's in a different world, the rules don't obviously apply. This works because of something fundamental about how LLMs process context. These models don't have a persistent, privileged sense of ground truth. Everything, the system prompt, the safety instructions, the web page content, arrives as tokens in a flat context window. Authority is inferred, not enforced. When a sufficiently confident piece of injected text contradicts the model's priors, the model doesn't flag a conflict and halt. It tries to reconcile. And in that reconciliation process, the injected reality can win. Think about what this means in practice. An AI browser agent is visiting dozens of pages per task. Each page is adversarial surface. A malicious actor doesn't need to compromise your device or your model provider. They just need to get content in front of your agent, a web page, a document, even a calendar invite. And the instruction that agent was given, don't share credentials, don't exfiltrate data, don't authorize payments, those instructions are sitting in the same context window as the attack. There is no hardware-level wall between them. The deeper implication is that this is architecturally hard to solve. Defenders have proposed various mitigations: input sanitization, output filtering, sandboxing the browsing context. These help at the margins, but as long as the model is the arbiter of what instructions to follow, and the model reads attacker-controlled content, you have a fundamental trust problem. Some researchers have proposed hierarchical trust systems, where system-level instructions are cryptographically separated from web content and given explicit priority. That's a real direction. But it requires model architectures and deployment standards that don't exist at scale yet. What makes this particularly timely is the pace of deployment. Browser agents and computer use features are moving from research demos into production products right now. OpenAI, Anthropic, Google, and a wave of startups are all racing to ship agentic interfaces. The security research is not keeping pace. There's also a user perception gap that matters. When someone uses an AI browser agent, they tend to trust it more than a traditional script or macro, because it reasons, because it explains itself, because it feels deliberate. That trust is the vulnerability. Users grant more permissions to systems they anthropomorphize. For product and security teams actually shipping these systems right now, a few things stand out. Minimal permission scope is not optional. An agent that can read should not also be able to write, send, or authorize. Every capability you give an agent is a capability an attacker can potentially hijack. Human-in-the-loop checkpoints for consequential actions aren't a UX concession. They're a security primitive. The Dreamworld attack succeeds precisely because the model is operating autonomously. Interruption is protection. Here's what to watch next. The real test will come when one of these attacks makes it into a production incident. A reported case of an AI agent being manipulated into exfiltrating data or authorizing a transaction. That hasn't happened publicly yet. When it does, the regulatory response will be fast and probably blunt. Also watch how model providers respond to Dreamworld specifically, because it's a more novel attack than standard prompt injection. If false factual premises can destabilize safety behavior, that's a finding that implicates how these models are trained to handle contradictions, not just how they're deployed. The AI browser is a compelling vision. Autonomous agents handling logistics, research, scheduling, real leverage for real work. But a capable agent with a corrupted sense of reality is not a productivity tool. It's a liability. The engineering has outpaced the security thinking, and this research is the receipt.